All right. Hello, everyone. I am Professor Caudill, and today we're on 25. So F-35 Lightning. F-35 is a short takeoff, vertical landing. Vertical landing. It's pretty interesting. If it does a vertical takeoff, 20 meters to 20 meters. Okay, so this is ground. It's going 20 meters. Let me make a little bigger picture. It's going 20 meters. And then follows a flight angle 30 degrees. So from here, we're going 30 degrees for 20 kilometers. Okay, so what's the final displacement? Okay, so we should probably convert this into kilometers. So what, there's 1,000 kilometers in a meter. So, okay, I guess the best way is to say this is 2 times 10 to the 1 times 10 to the negative 3. So it'll be 2 times 10 to the negative 2. So it'll be 0.02 kilometers. Okay, so 2/100ths of a kilometer. That's how far he rises. So, okay, so it shouldn't be too bad. All right, so um, let's say this is R R1 and this is R2. Okay, so this is 90 degrees. So we can say R is 0.02 cosine 90 I hat plus 0.02 sine 90 j hat. So we already know that cosine 90 will be 0. So before we even calculate it, we know what will cancel out. The thing this will be is 2 sine 90. So our calculator will do this for us. So 0.02 at 90 degrees. Okay, so 0.02. Okay. All right, so R2 is going to be 20 cosine 30 plus 20 sine 30. So 20, 30. So it's going to be 17.32 I plus 10j. $17.32 I plus 10j. Okay. All right. So the displacement, I think we just add it. So R1 plus R2, 17.32 I plus 10.02 j. Let's see what the book got. 25. Okay, so they converted it to meters. Should get the equivalent answer anyways. So you can see there. All right, maybe I can. Okay, so think about it like this. 17 is 17. Maybe our answer is a little bit more exact. 1.7 times 10 to the 4 is 17 times 10 to the 3 meters, which is 17 kilometers. They're getting I hat right, and then they should get the J hat the same. So I think our calculator is a little bit more accurate. They did 2 times 10 to the 4. Yeah, so they factored out this 20. And they do cosine 30. So yeah, our answer is a little bit more exact, I would say. Um, anyway, we got it right, so let's move on. Good start. Pretty cool F-35s. Pretty sick plane. All right. Acceleration vector position of a particle is 3ti plus 5j minus 6t k hat meters. All right, so this is your first time. These, this unit vector, this meters, this, and this, these are just, I would say labels. They're not, you're not doing any algebra to these really, unless you're doing like, you're doing actual vector cross hat. Okay, so that's the only time you do any like anything that's algebraic with these, or if you're converting units to another size. So determines velocity. Okay, so velocity is 6t I plus 0 j plus minus 6. That's an m. Okay, 3t, so 6t, 0, negative 6. Okay, what are its velocity and acceleration? All right, so you want the acceleration too. No problem. 6i plus 0j plus 0k. Okay, then you want v at 0. It's going to be 0. I plus 0j plus negative 6k. And you want the acceleration at 0. That is 6i all right. Easy enough. 27. Hope they're all like this. Hope I can just bust them down this easily. This whole hour. So the particles acceleration. Okay, so now they're going to give us the acceleration. Acceleration is at t. So t0. Okay, so velocity at 0, 0, and 0. What are the particles' position and velocity as a function? Okay, so if they're giving us the acceleration and they want to go backwards, so we're gonna do so integrals and derivatives are inverse operations. So we're gonna do the integral of a t dt is the integral of 4I plus 3j dt. So that's going to be 4ti plus 3tj is your velocity function. And then we integrate the velocity function. I should say plus a constant plus a constant. Okay, so this will be integral of 4ti plus 3t dt. So that's going to be plus c, right? Okay, so that's going to be okay, so it'll be 2t squared. T plus 1 is 2 divided by 2. 2 is 2. So we get 2's here. Plus 3/2 t squared. This is I. This is j. And we'll say C1t. We'll say that's k. I'm not really sure. 100% it's k. But it just looks so. It is, fits. It just fits so aesthetically. It's like, how can it not be K? Okay. So, 27. Find the equation of the path of the particle. Okay. It just seems kind of redundant. We found the functions. So aren't those equations? Aren't the functions? Isn't what we just found in A what we just doesn't A answer B? So not really know what I don't really know what they're asking, so I think I want to check the book to see. All right, so first, did we get the velocity? We got 4I 3t. We got 4t 3tj velocity. Okay, and the r is they are missing a constant though, so that's kind of weird. Book's missing a constant. So books make mistakes too. It's okay. No big deal. We just keep moving on. 2ti 3/2 t squared. Again, it's missing that constant, and that constant should have a variable t. From what I would argue. Okay, I see what it's saying now. So it's saying, so looking at this, we would say the x. Okay, so we would say, actually, we would be looking at this. So here we're gonna say, because the vector I is a unit vector for the x-axis, so we will say x of t is 2t squared. So I haven't done this before. That's kind of cool. Kind of extracting it out. And then y of t is 3/2 t squared. Alright, and I will go ahead and write the zt. I don't know if this is 100% correct, but we'll say c1 times t. Um, okay, so then they solve for t and they solve for y. I don't really know why they did that. Is that the question even asking that? Find the equations. Yeah, so the question doesn't even ask that. That's kind of weird, but they do get... Okay, I see why. Because they do want y. Okay, that is kind of weird. So why is it 3/4 and not 3/2 on the graph? It's kind of weird. Um, okay, so we want we want y in terms of x. Okay. So if I mean we can do the opposite of what they did. So if y is 3/2 t squared, okay. So we could say 2/3 y. Let's say 2/3. Oh no, we don't have to do that. 2/3 y is t squared. Okay. So now you're gonna plug this into this. Okay, you see how these can just be swapped. So you can write x is 2/3 y. Therefore, x is 4/3 y. And then 3/4 x is y, or y is 3/4 x, which is what they get. And they draw it on the graph. So it wasn't like that. That's pretty hard. To convert from words. Like we had to rely on the book's answer to get there, but so if we what could we learn from this? So from the position function from R, we can extract our x and y. Okay, and if they're wanting an xy graph, and these are Witten t's, we can plug in, we can swap the variables to get it. This might have been a harder way. I chose this substitution might be harder. I just wanted to do it like differently than the book to show how the algebra works out the same. Um, yeah, it's cool problem. Uses a lot of different techniques. So let's move on. All right. Boat leaves the dock. T0. Boat leaves the dock at T0. Okay. So I guess we just say T0 is 0. Okay. Heads out into a lake. So let's say this is a harbor. Harbor and lake. We have a couple boats. This one's going to go to I. Okay. A edge. A edge in the horizontal direction. What does that mean? What does that mean? A edge. Okay, first it would be an edge. So an edge in the horizontal direction. An edge. This sentence does not work for me. Okay, maybe it's because it's a different question. This is probably 34. So obviously there's a page break. Okay, so a strong wind is pushing the boat. Okay, so we have a wind coming here. Wind. Okay, oh, so the wind is actually a little bit slanted. Velocity of the boat. This is velocity of the wind. Okay. What is the velocity of the boat at T? We want to find T is 10. Okay. So we want. Okay, so if A is 2I, can we say I'm just doing the integral in my head. 2 I plus TJ question mark plus C1. Okay, so velocity is that. Okay, so the velocity of the boat is 2t plus I, so the I'm thinking if we need to do it again. I don't think so. It's just asking for the velocity. Okay, it is asking for the position after. So it's like, why would you? I don't know. No biggie. So R of the boat is t squared. Let's say C1 t j plus C2. Okay. So I'm gonna say x of t is t squared. Y of t is C1 t. Now, these are kind of hypotheses. I'm not really sure. When you get the constant after taking an integral, I'm not really sure if you can make that into a if you can just slap a j vector on it, a j unit vector. I don't know if you can slap a unit vector onto a constant after doing an indefinite integral. But so I'm just kind of testing the waters with that. Okay, so the velocity of the wind is 2I plus 1j. Therefore, the position vector of the wind is 2t I plus t okay, we should specify C3. Okay, so these are the boats, so I can say x of the wind is t squared. The y of the wind is C1, no, is t. Okay. So let's say V total is the sum of V in, and we're gonna have two. We have a win. Obviously we have two, so it's going to be 2t plus 2 okay, so it's like, do I write a j here or not? I don't really know. But we're gonna get 2 plus 2ti plus 1 plus c1j. That's my total velocity. So they want the total at 10 seconds. Okay, so that's going to be 22i plus 1 plus c1j. Okay, so that answers part A. Position function is similar. So first off, this is wrong. This should be 2t. Okay. Draw, what is the position of the boat at 10 seconds? Okay, so our total is t squared I plus c1 tj plus c2 plus 2t I okay. Let's say c2 plus c3 equals c4. Therefore, we will have 2t plus t squared I plus c1 t, no, it'll be t, okay, let's write brackets, t c1 plus 1 j okay. Oh, and then plus c for k hat question mark, because I don't really know if I can do that yet, but I'm gonna say that answer is B. Okay, draw the sketch of the trajectory. Okay, so now they want to do that. So now they want to do so x is 2t plus t squared. Okay, y is t c plus 1. Okay. So they want us to express this as xy. Okay, so we can write y is we have to isolate x. We have to isolate t. So okay, so we have to do this is you have to do like a quadratic formula, don't you, on this one? All right. I'll do it in a few seconds. So solve 2 times t plus t squared. Solve for x. No, solve for t. Okay, yes. So we get t is the negative square root x plus 1 or square root x plus 1 minus 1. Okay. So y is I think we would choose this one. Just makes more sense to me. So square root x plus 1 minus 1 c1 plus 1. Okay. So now we do some factoring. Y is c1 square root x plus 1 plus square root x plus 1 minus c1 minus 1. Okay. So this is our final equation. So you wanna see this graphed. We will try it. Okay. Y is c times square root x plus 1 plus square root x plus 1 minus c minus 1. Okay. At c is 1. This is our function. So let me copy this. Okay, so you want to see it vary depending on our constant. Function is in this space. So this is the speed of the boat as it increases with the wind. So you can see there's several forces at play here. So it's getting accelerated. The boat is accelerating itself with its motors. So you might see, so remember our first acceleration of the boat is actually a constant. So acceleration is a constant. Let me see if I can do d. Yeah. So yeah, that's my answer. I don't know if the book likes it. It's an even problem, so we can't you really check the answer. We could get a second opinion, but I'm happy to move on. Okay. Time's flying by. All right, so position of a particle. So t greater than 0. So it's r. Okay, so particles moving like this. What is the velocity? Velocity as a function of time. Okay, easy enough. Velocity is 6ti minus 7, 14, 21 t squared j minus 10t. Okay. And yep, so no constants, so what is velocity at t is 2, so you want v at 2. Okay, that's going to be 12i minus 4 times 21. 4 times 21 is 84. Okay. J minus 20. Okay. That's a velocity. What is a velocity? What is a velocity at 2? The velocity at 2 is this. Does that make sense? So what is this saying? It's saying v x velocity in the x direction is 12 meters per second. The velocity in the y direction is negative 84 meters per second. And the velocity of the z direction is negative 20 meters per second. So at t equals t equals 2. That's true. Okay. So you can see if it's going, so let's say, okay, so if it's going 12 this way, okay, so it's being accelerated this much in this direction, being decelerated this much in that direction, then it's slowing down this much in the z direction. Okay, so if you express all these as a vector, you would just take, it would be whatever that is. Whatever the actual point is, that would be like your actual. So these are like components of one big vector, is one way to think of it. Okay. What is the speed at 1 and 3? Okay. So you want the speed at 1 and 3. So velocity at 1. I think the speed is the absolute value, so we will do velocity at 1 is the absolute value of 6i minus 21j minus 10k. So the speed is 6i okay. So that's the speed, and you want 3 seconds. Um, 6 times 3, 18. 3 squared is 9 times 21. Okay, minus 189, j minus 30. Okay. So the speed okay. and then you want the average velocity. Okay, so the average velocity between one. Okay, so this will be average velocity is the position function. Okay, I remember this because I've made this mistake before. So V average is R T2 minus R T1 T2 minus T1. Okay. So they want 3. They want average velocity 2 and 1. Okay, 2 and 1. 2 and 1. So it'll be we need 3t squared minus 5t squared. Okay, so that's our R. Okay, so it's going to be at 2 and 1. Okay, so it'll be 3, 2, this minus this. So we 3, 1 squared I minus 7, 1. Is that cubed? Yes, it is. Minus 5, 1 squared K. Okay, and then all of this is divided by minus 1. 1. Okay. So we have a lot of numbers here, but this is going to be so it'll be 4 times 2 squared is 4, 12i. So we will have 12i minus 4, 8, 8 times 7, 54, no, 56. Minus 4 times 5 is 20. Minus 3i minus 7j minus 5. Okay. So I'm going to go ahead and distribute the negative sign. Okay. So that's going to be our final answer is 9i minus 49j minus 15k. All right, drum roll. See what the book got. Okay, so part A, 29. Okay, so we get 6t, 21t squared, 10t. All right, so we have a mistake here. So we made a notation error here, right? We went too fast. We wrote this down wrong. T, like I know I saw the -2, but I didn't write it. So that's kind of annoying because that means you know, everything else is wrong. So but no problem. And then this would be 10. So, yes. Okay, so obviously if we get this wrong, then the velocity is wrong, then this is wrong, so this should be, I mean, the only thing we got wrong is the K element. Everything else should be right. So we can check everything else. 6t, 42. Okay, so why is this 40? Why? Okay, 21. They found acceleration. Did they ask for acceleration? What is the acceleration? Okay, well, it's easy. I mean, we could have found acceleration too. No problem. 6t. Okay, so yeah, we didn't use the acceleration at all. So v2. I'm just checking the I and j's because we know we got the k wrong. 12, negative 84. Okay. Okay. And they want v at 1. Okay, so they got 24. Six negative 21. Okay, so how did they... Are they saying speed is the dot product? 6 negative 21, 10. 6 negative 21, 10. Let me do a quick Pythagoras theorem. 6. Okay, so yeah, they're saying the speed is a Pythagoras theorem. Okay, so yes. I get what they're saying. So they're saying v at 1 is, so we don't need the absolute values. When we find v at 1, it's 6i minus 21j plus some number k. Okay. So they're saying the speed is the norm of v1, which is mute for a second. So I'm not upset about that. Good lesson, I guess. So remember, speed does not have a direction, so it's simply the magnitude of the vector. So, and then they do the same for here. So you see the speed is changing. Okay, so then what's the RT? Do we get RT close? Definitely should get these first two numbers, right? But we got, didn't they ask for a position at T is 2 and 1? 29. What is, okay, I thought they asked for the, yeah, they did that for the average velocity. So part E, So part E, the book's not even answering this. Um, the book gave you the position function, which we get close to right. It would just be a -2, but we're pretty much spot on. The book doesn't even do the average velocity. You see, so I think it's funny because we're like the book is making as many mistakes as me. The book just didn't answer part E, so that's it's kind of funny. So yeah, we got 4 minutes. We can send it to 30. Um, acceleration of a particle is a constant. Let's say it's gravity, okay? Um, at t, so t is 0, so velocity at 0. Okay. Velocity at 4 seconds is okay. What is the particle's acceleration? So, interesting. What is okay? We're just gonna say a. A is constant. So a. Okay, so what is a given v and that? Okay. Velocity. Man, this is a tough problem. So what are we gonna do? We're gonna take this. I went. Maybe we're missing something. So 10i, 20. Okay, so let's use our feature extractor. Twenty. Okay, and then okay. So we want to find acceleration given to okay. So we know acceleration dv a. Okay. What if we wrote these as integrals? What if we wrote 4, 0, that won't work either. Okay, so I need assistance given to velocities at certain times. How do you find the acceleration? I know there's a function we have to use. Do they want average acceleration? Maybe that's all we can find. So they're saying it'd be 10 minus 10j minus 10I over 4. So they're saying it would be 5j. I think that's what they're saying. Yeah, it's kind of like average velocity. It's just the only thing is I wish they would have said what's the average velocity. It's just kind of vague, you know. Um, yeah, tomorrow we'll start it with 31. So I'll see you guys and have a good one.